Hello, everyone. Come on in. If everybody could go ahead and chat me your first and last name, I'd appreciate it. We'll use that as our role today. Thanks, Shane. Also, if anybody has any problems with your name or anything else appearing on the internet, you need to let me know via email or text message very soon. So, now will be a good time. Uh, just because I have to do some editing and stuff. If any of your names pop up, and I don't want, like I said, I don't want to put anybody's name on my YouTube channel, which is where this video will go after I finish recording it. So I don't want anybody's name to go up on the internet unless they're okay with it. So if y'all have any issues, and I don't need to know what the issue is, you just let me know that you can't have your name put on the internet or your face or anything like that. Just let me know specifically what can't be put up there, and I would be very appreciative. I'll try to say that again after everybody else is here, but I want to say it now before I forgot. At least it'll be on the transcripts and the meeting that I post so that anybody looks back at it, they can see what they missed. Those of you who are still coming in, I just finished telling everybody to chat me your first and last name. So type in your first and last name in the chat box and send that to me. That's going to be my role for today. And I also told them that you need to let me know via email or text message ASAP if you have any problems with your name or likeness or anything being put on the internet, as this video will be posted on my YouTube channel when it's done. So again, make sure you do that. Still got students coming in. Do it one more time after 10. You're welcome to ask questions now, too, by the way. You can sort of treat this like a little bit of an office hour type thing. So if you have any existing questions regarding lecture material, regarding the syllabus, regarding how to solve a problem, or anything like that, by all means ask me. Sorry. I like I was getting ready to eat somebody. All right, now it is officially 10. I'm still going to give a few more minutes in case anybody comes a little late before I make my announcement a third time. But seriously, anybody have any questions? I'm going to keep my camera off. Is that all right? Yeah, I shouldn't need you guys to have your camera on at all. You're welcome. You're welcome to have it on, but that's especially helpful if you're one of those people that don't want your face on the internet. Maybe you don't care about your name, but if you care about your face being on the internet, then by all means, make sure you don't share your face. But it's okay. I like it. I like the chance to help learn my students' names. So, as I told you guys, if y'all will put your a photo in with your SIS file, so that when I pull up your roll, that I can see you both in my Canvas as well as in SIS. I give everybody 2 extra credit points on their first face-to-face test if anybody does that. So, by all means, please consider doing that.
I'm sorry, I missed the first half of that.
Oh, no problem. I'm getting ready to restate everything, so don't worry about Liam. I'm trying to make sure everybody gets in here. It looks like we're about full. If I remember correctly, I think we have 22 students in the class right now, and we got 20 in here. I suspect some might not be able to come or whatever. So what I was saying was, one, I want everybody to chat me your first and last name. That's going to be our role for today. So everybody chat me your first and last name if you haven't already. Someone asked about whether they can type work on a lab report. Yeah, I just advise people not to waste time doing that in terms of using the equation editor and stuff like that. If you want to, it's fine. It's just that can take a good deal of time to make it all neat and stuff. Uh, it's probably way more efficient to do the calculation by hand, take a photograph of it, and then paste that photograph into the Word document. But yeah, you're welcome to type it in if you want to. Okay, so what I was saying again was one, I want everybody to chat me your first and last name as role. Two, I'd need everybody that might have a problem, that has a problem with their name or their image or their face being posted on the internet, because this video will be going up on my YouTube channel later. So if anyone has any objections to their name appearing, generally the names don't appear, but occasionally they can. And the same thing with your image. If you actually use your camera and show me your face, sometimes your face will appear. So if you have any problems with that, you need to let me know via text message or email like immediately. So because I have to do certain editing things to make sure that that doesn't happen, and so on and so forth. I've never had anybody that needed so to keep their face or name off the internet. So I'm not sure exactly how I'd go about doing it, but that is something that I want to make sure that everybody has the right to their privacy regarding that. We have no uh, legal ability to just post, your guys' names up on the internet without your saying it's okay or without your refusal to object. So that's why I'm telling everybody, please object if you have any problems, and then I'll do whatever it takes to make sure it happens. Uh, Also, this time can be used as a sort of office hour once I get you through the part of showing you how to get the lab started. This is honestly probably the one lab that really doesn't matter whether we do it face to face or in person. This lab is called analyzing motion graphs. Oh, get ready to go. I'm sorry. And it's a continuance of what you started learning last week in the motion detector lab. The motion detector had a very specific set of coordinates it uses. For instance, if your motion detector, which was sort of shaped like a fat calculator, so if you imagine this is your motion detector, there was this sort of cone that went up this way, this way, this way, and this way. A cone of sound, ultrasound, that pulses that were sent out, they would bounce off the objects and then come back. And then you using some electronic circuitry, it could sense, what beams were sent out and how long of a delay there was, as well as what the temperature in the room was, so that it could readily calculate the velocity of sound. And then using that, you can make graphs of position on the vertical axis versus time on the horizontal axis, or velocity on the vertical axis versus time on the horizontal axis. But the coordinate system for this motion detector was that the positive x-axis or the positive distance axis pointed out from the face of the motion detector. This lab's a little different in that we're going to take videos, actual MPEG video files. We're going to upload them into our computer and into a software package called Logger Pro that you guys can download. And when you download them, you can then analyze the videos. So this is a really good and neat thing that modern cell phone technology has given us. In fact, there's a bunch of free apps that do it on their own just by downloading the apps. So you don't even need Logger Pro necessarily to do the analysis. There's some parts that obviously Logger Pro does way better than some phone app. But if you come up short, you can always just analyze the videos and analyze the graphs and that sort of thing without the software. But I highly recognize there is no notification on Canvas nor Pearson about the motion detector lab. Did y'all not do motion detector lab last week? Maybe I'm misremembering.
Well,
We
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 had Martin
didn't
Luther
have our
King Day.
lab last week because of Martin
Oh,
Luther
that's
King
what it
Jr.
was.
Day.
Thank you. Thank you. No, no, you guys don't have to do that at all. I've just prepared for the wrong lab because I completely forgot. That's on me, guys. Not your fault at all. Okay, so what I think is best for us to do then is probably, and I'm hoping this is not going to be too much of a problem. I'm going to go ahead and do the motion detector lab today because this one is so amenable. Excuse me, I'm going to do the analyzing motion lab today because this one's so amenable to being done online, and I feel like you'd sort of be robbed if we did the other one online. Uh, yeah, that's right. That's exact. I did do it I did do it with the other with another 241 class. That's why I remember doing it. So sorry about that. Yeah, you guys were off on Monday for Martin Luther King Day, so yeah, you completely didn't do it. Thanks for announcing that to me, Katie, and thanks for everybody else that replied. So we'll just stick with the preparation of what I'm doing, and what I'll do is I'll talk to the lab manager and get them to leave the equipment up because actually, to be honest with you, when we do the analyzing motion lab, you don't need any equipment, so it won't necessarily have any problems for us to take it out of order. So we're going to go ahead and do the analyzing motion ones. I think in some sense you might actually find this one to be a little easier to do than the motion detector. Motion detector had a little bit of concepts that were a little bit abstract, like that motion detector having a coordinate system, and therefore, positive slope distance versus time graphs automatically meant that the object was moving away, whereas negatively sloped distance versus time graphs meant the object was moving towards the detector, and stuff like that. So that was a little bit of a problem. So let me back up then and say again, we're doing the analyzing motion lab, and we're going to be using Logger Pro software. As I said, there's also other software you could use. I've used some of this free software that I can find on the internet for my cell phone. For instance, to analyze my, I had a Chihuahua named Hercules that he got the zoomies like a lot of dogs do, and I saw him run across the living room one time, and he jumped, but he overestimated his speed evidently, and he jumped for my couch, and like he peaked. And then he started to decline in his projectile motion and just hit face on into the front of the couch. And I happened to catch it all on video. So I was curious. He didn't yelp at all, so it must not have hurt him. All I can think is maybe it embarrassed him a little bit, but he kept getting it, so I don't think it even embarrassed him. But either way, I analyzed the motion and found that he actually took a 3G acceleration from hitting that front of the couch. So that's the kind of analysis you can do. All I had to do was let the computer know exactly what thing I'm looking at, because as you've probably seen in these tests of whether you're a robot or not, sometimes just straight photographs have computers have a hard time of looking at a photograph and determining, what part is what, where are the edges of this human being, or where are the edges of this cog that we're studying, or whatever. So that's one of the main things about this lab is you're going to take this program Logger Pro and or some other programs, and I highly encourage you guys to use other programs for extra credit if you do it in addition to what we do on lab. But if you can't get the Logger Pro downloaded and working properly for your computer, or if one of you can't among your group, because you guys can still group up like a group like you normally do and just communicate online or whatever. But if you as long as one of you can get the Logger Pro downloaded and ran, then you can go ahead and run with the lab. But if you go on in addition to it and maybe use some of the online apps like Phybox, Phybox, Box, and some of the other apps for iPhones and Google phones or whatever, Samsung phones, all those different operating systems have different programs you can download. So if you do that in addition to, I will definitely be giving you guys extra credit. You just have to, seamlessly tie it in, or even maybe put an addendum and say, here's the analysis I got by doing it with this app or something. That would be perfectly acceptable. You could even cut and paste the exact same lab report down below and just point it out to me, and I'll make sure I give you guys appreciable amounts of extra credit for that extra work. But here's what you're going to do. You're going to take these videos. I actually have the videos put up into the module for this week. And notice this week's module has week 3, but then it has week 3 lab module. My modules are getting a little heavy, a little thick with a lot of different links, and sometimes that's a little intimidating for my students. So I'm probably going to go back and take week 2 module and put a lab module next to it, and then put week 1 module and separate that and make a lab module too. But it's a bare minimum. I'm starting this week at lab 3. I'm going to have a module for the lecture, and then I'm going to have below it a module for the lab. And you've already seen that. That's where the document is right now. But either way, uh, in that area, it's going to have up at the top, it'll have basically the lab report, which is the Word format document that I tell you I always give you on your lab. And then below that's what we call an addendum. And that addendum tells you how to implement this lab, which was originally created to do at school on school computers, and it tells you how you can go about implementing the lab without being at school. And then the next thing on the line is where you actually turn in the lab report in that finished format. Again, in the turn in area, I explain what you're supposed to do in all the lab reports, so you can reread that in case you forgot. I should have your first lab graded. If not today, it'll be graded tomorrow. And you might and probably should look at that grading before you turn in the next one. Not only that, I want to remind people that when I post these docs, they'll say .txt or something like that, text documents that say something like comments. Those are comments that I've made on previous lab reports, and you being able to read the comments on previous lab reports before you turn in your new lab report gives you an advantage of not making the same careless mistakes that previous students have made. I don't think I've posted that document yet, but I will post it. So I think I have one for this lab, a text document that has all the comments I've given students in the past. So when you go to turn in your lab report after you've read inside where you turn it in, it tells you all the details of what's required of you on a particular lab report, which includes basically you taking a Word document that I provide, you inserting typeset text in a color font other than black. So anything you type into the lab report has to be in a font other than black, and it's got to be obviously different than black. Like if you do it really dark blue or really dark green and it's hard to tell that it even differs from black, then it's not going to be of any use to me. The whole purpose for me in this is I need to quickly be able to look at the lab and say, what did the student add versus what was already in the lab report. You'd be surprised how many times students write things that sound just like something the lab report would have put in. And that sometimes is a good thing, sometimes it's a bad thing. But the main thing is that's why I want the font other than black. Medium blue is a good one. Medium green is a good one. Yellows are not good. Reds are not good. But probably a dark red I wouldn't mind too much. Now, in addition to that, you are supposed to add sample calculations. You're supposed to usually type in, sometimes you might have to write the answer to any question. So if you see a question mark in the Word document, you're supposed to click your cursor right to the right of that question mark, hit return, 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 then move up in the middle of the white space between those three returns and type your answer in a color font other than black. Every type of calculation you do in a given lab report must be shown as a sample calculation, every type. Okay. So, for instance, one type of calculation is calculating an average. So, if in part A of the lab you calculated the average of the length of some block, and then later you calculated the average value of 1/2 g, if you showed me the sample calculation of calculating the average of the length of the block, you don't have to go back and show me an average calculation for 1/2 g, not the average calculation. The formula that you use to calculate 1/2 g, which was h over t squared, for instance, that's another type of calculation. So you'd have to have a sample calc on that. So that's some of the stuff that's supposed to be in the document. Any sample calcs, like I said, you're welcome to type them in and use the equation editor of Word. That's really a pretty nice looking little equation editor, and things look really nice. And you putting in the numbers with the units, which is what I require at least on the first step of a sample calculation. That all looks really great with the I mean, with the actual equation editor. But I don't want you guys to feel like you need to do that. I don't want you wasting that amount of time. If you have the time and it's something you're interested in, go for it. I'm not going to take off for it. But the quickest way would be do the calculation by hand, again, showing units at least when you first put the numbers in, and obeying Sig Fig rules, and do the calculation, take a photograph of it, then insert that photograph exactly in the lab manual or in the lab write up where they ask for that calculation, okay, or where you have to do it as a result of your analysis. The same thing with graphs. If you're made to make a data table or make a graph, right where you're told to make that data table or to make that graph, or right where you're supposed to analyze that data table or data graph, you're supposed to insert the data table or the graph right there. That means that sometimes you'll have two different options of where you can put it. I'm not going to grade it as wrong in either scenario if you do it in the procedure section because that's where they told you to do it, or if you do it in the analysis section because that's where you had to do it. Both are completely acceptable. What's not acceptable is saving stuff till the end. Again, if you did some extra analysis, that's kind of stuff you'd save to the end, and you'd make a big non-black typed font thing saying, "Hey, here's some extra work I did," and you just put it at the bottom. That'd be great. I will totally respond to that. Uh, so that's the way your labs generally are working, and this one's not going to be any different. You're just supposed to analyze graphs, and then at the end of this particular lab, there's actually a quiz section, just like the motion detector lab, which we'll have to do next week. That one actually has something called a summary section that's just like quizzes, but it's sort of your first instance of doing analysis of graphs. But because we're doing this one first, this one's going to be your first analysis of graphs. So feel free to keep that in mind and use it accordingly. Let me tell you specifically the types of questions that I'm expecting you guys to learn from this lab, which is the same thing I expected you to learn from the motion detector lab. And if you want to know more about that motion detector lab, I already posted my other PHY 241 classes lecture on that lab, only their lab they did at home. So they had to basically analyze the data without actually running it themselves. But you can find it on my YouTube channel. You'll see it's Intro to Motion Detector Lab. So by all means, look at that. Uh, Now that it looks like I've finally got just about everybody, I just saw, two more people move in. I want to reiterate, everybody that's here, if you haven't already, please chat me your first and last name. And everybody that's here, please make sure you send me a text message or a email and tell me if you are not okay with having your name or maybe even accidentally your face appear on the internet through my YouTube channel, because all these videos, every time I make them, I put them on my YouTube channel, and I make sure all my students are aware of this, so I'm not outing someone as taking a class in my class or anything like that. In fact, there's no I don't even stop non-students from attending these lectures. So even that's not necessarily telling anybody that students are taking my class, even if they see your name. But the main thing is, there could literally be someone in hiding from the mob or something. So I don't want to endanger anybody or make someone just feel uncomfortable. So I don't need to know the reason. All I need to know is if you don't want your face or name to be posted on my YouTube channel on a video, you need to send me a message saying exactly what you don't want posted on the internet by email or text message. Okay. So this lab, as I was saying, is the analyzing motion graphs lab. Let me go ahead and share my screen with you regarding the actual lab. First off, I got to open it up so I can get to the actual lab document, and then I'm going to uh, open up the addendum and show you that as well. But first, I need to show you the lab document. Actually, I'll probably just start from here because this will help you see something too. Yeah, that'll work. All right, so I'm going to go ahead and just share my computer screen with you guys. And let's say this one right here be the good one. Okay, so this is our TCC VHY 241 D01B slash L01B Canvas page. You can see these areas that aren't green like that. Those are ones that I haven't published because they're usually me where I put stuff and don't want students to see. Same thing here. But that's also the problem. Like when you guys are looking for something, and I'm like, it's right there. Well, I can have everything in this module completely published, but if that little thing's not published, you can't see it at all unless it happens to be somewhere else. So that's often the problem with you missing stuff. What I wanted to show you is this week's lab or excuse me, this week's module. Notice this week's module, I didn't change the date yet for the lecture one. I will change that in a few minutes, but you can see these are all the optional videos I've given you because this week we not only finished off chapter two, but we jump into chapter three, which includes one of the big hurdles. And I shouldn't even say a hurdle. It's not one of the skills that really trip people up, but about every semester I usually have 1 to 3 people out of 24 that really don't understand vectors and can't add them and can't make them and stuff like that. That's the kind of thing that prevents you from succeeding in this class. I mean, like, period. Like, we don't want you to complete the class with any grade other than F if you can't do, uh, simple vector analysis, which means maybe taking a formula for the size of a vector, for the magnitude of a vector, and then converting that into an actual vector with, x components, y components, and maybe even z components, and then being able to add two or more vectors, being able to subtract two or more vectors, being able to multiply a vector by a scalar, being able, once we get to later in the course, being able to perform a dot product between two vectors, which is a scalar product, or being able to form a cross product, which is a vector product between two vectors. Those are just absolute skills that we don't want you succeeding, passing the class unless you can do them. They're not optional, in other words. Okay. Not only that, that's sort of what they might call the low-hanging fruit of many other majors. This is part of the reason that med schools often require calculus-based physics to even be accepted, because they want to show that you're capable of doing this higher order abstract thinking, or you're not eligible. They don't want you to be eligible. Your brain's not ready yet. Again, that's not the way a community college or me as an instructor runs things, other than with regards to the course. And you can't survive PHY 242 if you don't learn the vectors analysis of 241. So in that sense, yes, I'm an absolutist. No one passes unless they can do that. But in general, we never at a community college level, at least me nor any of the lovely instructors that I know, uh, ever have a quote unquote weed out course. We try to fight weed out courses and make those as accessible as possible. All right. So, anyways, back off my soapbox. Because of the importance of this vector stuff, I've got a ton of videos that show you how to add vectors and stuff like that. I've got something called the world's greatest vector addition problem, and it's really, nothing any better than any other vector problem. It's just that I took the time to write out vectors, all the different ways you could possibly be given the vectors. There, I can give them to you in magnitude at notation, which means the magnitude of a vector at such and such an angle. When that angle's positive, we're supposed to understand from our math experience that that is an angle that's measured counterclockwise from the positive x-axis. So that's what the magnitude at notation is. If it happens to be magnitude at a negative angle, then it's an angle measured clockwise from the positive x-axis. But then there's also compass heading angles. There's angles such as east of northeast, that sort of stuff. There's compass headings of 13 degrees, stuff like that. So in this, world's greatest vector addition problem, which there's a couple of them that I've done, you'll find versions of vectors being expressed in ways that you could possibly be tested in this class and later tests in later classes in engineering and other sciences. So that's why I wanted to give you a lot of extra tools in case anybody are running into problems. And because I've literally had some students that have taken my class. In one case, I had a really good guy, a smart guy. He really wasn't. He didn't have anything wrong with him or anything like that. It just something about vectors wasn't clicking with him, and he ended up taking my class like 4 times and failed every time. Uh, Not because I wanted him to, because he could have been, in my estimation, a really good double E. He wanted to be an electrical engineer. He had a lot of electrical engineering experience in the Navy and everything. I mean, he was a good guy. He was a smart guy. He was a hardworking guy. But I guess he just was given a technique to add vectors a little too early, and he never internalized it where he could make sense of adding vectors. So don't do that, please. But in addition to that, there's a lot of kinematics problems, so on and so forth. Here's the homework. You can see the due dates have been adjusted, the due dates, since we didn't finish chapter 2 last week. I'm allowing you till the 28th to finish chapter 2. And I've also pushed the due dates for chapter 3 back a little bit. And since there's 3 for chapter 3, I went ahead and moved one back even further. But now let's go on to the lab module. So this is a new thing. So this is the document where it tells us how how to do the lab. This is the Word document that I've been telling you guys about and that I give you every week. You can see right here, this is a video of Dr. Wright. It's either his grandson or his grandson-in-law or his son-in-law or something like that. But he went to a gym, and over here you see right in this line is a meter stick. There's another version of the video which is floating around and shouldn't be available, but just in case y'all end up running into it, because I might have included it in my files and not known it, there's another one that has a 2 meter long meter stick laying there, and it's almost the exact same video except it has a 2 meter long stick. So look at it and then say, well, compared to him, this meter stick is shorter than him, so clearly it's a meter stick. And if you see one that's obviously longer than him, then you're going to know that that particular meter stick is 2 meters long. So just keep that in mind. But this is like an actual photo of beginning of one of the videos, and it shows you what the Logger Pro program has for buttons. The thing with the computer and analyzing videos is the computer just knows pixels. It knows there's a certain amount of pixels per inch horizontally, and there's a certain number of pixels per inch vertically. Sometimes those two numbers match, as far as I know. I think they're always supposed to, but I don't know the technology that goes into making monitors nowadays, so I might be wrong about that. But that was the way it used to be. What I'll also tell you though is the total width is a certain number of pixels, and the total height is a certain number of pixels as well. That part I still know is active, but that's what a computer program knows when it's given a video, is it just knows pixels. So it can't tell, for instance, like I said, the "Are you a robot?" test. It can't tell where the edge of this person's pants are, where the edge of his shirt is, where the edge of his head is, or any of that kind of stuff. It can't identify people from all the video necessarily. You have to, in some sense, do that. Now, what it does do, and this depends from operating system to operating system. I remember when I was learning to write code for Macs. I think at one point we actually had Mac was designed such that their origin of their axis is in the top right corner. It might have been the top left, but I think it was the top right corner of any window it opened up. So that would automatically mean that down is the positive Y direction and left is the positive X direction, or some crazy stuff like that. All of that is a part of the operating system, and it literally can change from Windows to Linux to Mac OS. But the important thing is whatever in situ coordinate system in the system coordinate system that the operating system uses, this program Logger Pro interfaces with that and tries to make it into one that reads not in pixels but rather in meters or centimeters or feet or whatever units you put in. So when you're given a video, even in Logger Pro, you first have to make sure Logger Pro knows how many pixels left corresponds to 1 meter left and right, or how many pixels up and down correspond to 1 meter up and down. And the way you do that is you normally set scale. That's what this button right here is. And then you click at the left edge of something whose measurement you know, and something that's about the same distance away as the object that you're studying, which in this case is going to be the ball that this young man shoots. Notice he is exactly the same, or very close to exactly the same distance away from the camera as the meter stick is. Obviously, going at a diagonal is a little bit bigger than going straight on, but the main thing is he's in the same plane as the meter stick, and that plane is perpendicular to our line of sight. If you're not perpendicular to the line of sight, then things are off. So, for instance, if we videoed a car going partly away from us but partly left and right, we wouldn't get an accurate measure of his speed. We'd only get a measure of how fast left and right they're moving, not necessarily how far fast forward and backwards they're moving. So you want the plane of the action that you're trying to analyze to be perpendicular to the line of sight from the camera. And the line of sight is like a line that you'd imagine leaving the center of the lens of the camera and running right into the object you're studying, which in this case would be a basketball. Okay. Now, if the basketball stays in one plane, then you just want to make sure that line is perpendicular to that plane. If it's not, then there might be a problem, but it might just be, uh, you know, like in this case, the ball is going to start a little farther away from the camera, and then if it reaches its max height right dead center in the middle of the camera, then it's at its closest point of approach to the camera, and then if it continues on, it's going to move farther away again. None of that matters. Okay, that's the main thing to think of. So when you get the video, you're going to have to set a scale with something about the same distance away as the object you're studying, which, like I said, in this case is a basketball. Later on, it'll be a ball thrown up by a little girl. There'll be a truck riding by. There'll be a fire truck riding by. There'll be a little girl riding a bike riding by. There will be an explorer riding by, and ultimately a space shuttle. So, and there's a lot of different stuff we can analyze. But the first thing you have to do to use Logger Pro is you have to set up a scale so it knows how many pixels equals 1 meter or 1 centimeter or whatever. Then the next thing you got to do is you've got to set the video in motion. Now, Logger Pro automatically dices it up where when you hit play, which is what these VCR looking buttons down here are, this one's play, this one's stop, this one's go back to the beginning, this one's fast forward, this one's reverse. But the main thing is it's also next frame as the picture shows you. But when you click that next frame, it literally only chooses a certain amount of time to progress forward in the video, like on the order of an eighth of a second or something like that. So what you do is you set the video in motion, which is going to show the person take the ball, do this, and then like that. Well, all that time where they're pushing, they're actually applying a force to the ball. Applying a force to the ball, which is, later we'll learn in Newton's laws, causes an acceleration, and we're not trying to study that acceleration. We're trying to study the motion of the ball under gravitational acceleration. So what you'll do is move the video forward, forward, forward until it leaves the person's hand. Once it leaves the ball leaves the guy's hand, then we want to start studying the ball. So what you do is you move it forward a frame, a frame, a frame until the ball is no longer touching the person, and then you use something. Add a point is what we're talking about here. So you use something, a point, to indicate exactly where that ball is. Now the ball is pretty small compared to the field of view, and you can expand the size of the video window, and you should for best analysis. But since the ball is so small, you could probably just choose the center of the ball to hit, and that would be fine. The main thing is you need to be able to find the same part of the ball to hit at each little part of the video. So what you're going to do is once you get it ran up to the point where the ball has left the hand, you're going to add a point, like I said, probably at the middle of the ball. And when you add that point, it's going to advance the video forward a little bit, and then you're going to find that same spot on the ball and click again. That'll add a second point, and then it'll also cause the video to move forward. Add another point just again by just clicking the center of the ball, and keep on doing that until just before the ball hits the ground. You could analyze the motion of the ball hitting the ground, and that would be a whole different analysis, but it's not something that is relevant to this particular lab. It's not even relevant to this chapter yet, but later on you could in principle use it to analyze, how well the ball is inflated. Does it bounce according to the rules of NBA basketball or whatever? So that's how you have to do this. And then when you do it, you'll have a series of points that show the position of the ball at different points in time, and they'll sit there on top of that video. And then the program will actually make a horizontal velocity versus time graph. It'll make a vertical velocity versus time graph. It'll make a horizontal position versus time graph. In other words, what's the x coordinate of the ball at each point in time? And it'll make a vertical position versus time graph. In other words, what is the height of the ball at each point in time? It can make all of those different graphs. It can even make an acceleration versus time graph, even though we're not studying that. But in principle, it could make an acceleration versus time graph as well. Once you're done with that, then you can analyze it, and you can see stuff like the acceleration of gravity is not going to be that hugely close to 9.8. It turns out that the small amount of backspin that a basketball has put on it and the small amount of air resistance that a ball encounters is enough to make G significantly different in this particular lab, where you're just shooting a basketball from a person's hands. It's going to travel a trajectory like it would to make a basket, but they're not shooting at a basket. They're just shooting it so you can see the nice parabolic arch it makes. Okay. So that's the big plan with this lab. It tells you exactly how to do it using Logger Pro, so on and so forth. Then it tells you other things to do. So this is like the different graphs. In fact, when you make that first graph, it usually shows at least two graphs. Sometimes it shows three or four, depending on what kind of motion you're studying. And then you can just go through and alter the graph so that it shows the one you want. Like this one right here. I don't know if I can even zoom in it to make it any bigger. Oh, I did not mean to do that. Let's see if I can go back to it this way. Yes, I can. Okay. So it can make these graphs, but the label on the left-hand side shows you what the graph is. Notice it's got a green label that corresponds to the green graph. It's got a graph. It's got a red label that corresponds to the red graph, so on and so forth. Then there's other ones we're going to do as well. Other types of motion, like I said, there's a little girl riding a bike. There's a fire truck going by. But in each case, you want to choose the object that you're going to click on in such a way that it's seen at every scene. So you need to watch the whole video at least once just to see the object, whether it be a basketball or a softball or a fire truck or a Ford Explorer or little girl's bicycle wheel or whatever. You need to watch the whole video and see what parts, if any, are visible the whole time that you want to study the motion. Because if you choose, for instance, one of those parts that disappear, you're going to have a missing data. So what I've always found that's easy to find, for instance, on the fire truck, is there's these chrome handles all along the side of the fire truck, and if you take one of the, like the bottom left or the top right or the bottom right or the top left corners of one of those things, those are normally easy to be seen, and you can quickly put the crosshairs right on the corner of it, and there's no ambiguity that you're putting it in the right spot. So that's a good thing. I think later when we do the bike, they tell you the height of the tire as our scale. So you're talking about taking the tire and measuring it from the treads on the left hand edge of the tire to the treads on the right hand edge of the tire. That would be the whole diameter of the tire, and that's what they're basing that on. So you're supposed to do that, and then the lab gives you the measurement of that tire so that you can actually put it in so that the Logger Pro will know the scale of the video. Okay, but these are all the different procedures. Uh, it tells you about all velocity versus time graphs will be straight lines. They'll either be horizontal or diagonal. That's a key thing to remember. There's also something back here. I think it's here. Uh, no, that's right. That was in the other way. So when you make these graphs, they're mostly going to look just beautiful like this because you're doing really good data that's made up by reality. So unlike the motion detector, which you guys haven't seen yet, it'll have the motion detector will have spikes all over it and stuff like that, and you got to sort of idealize the graph. That's sort of what's going on here in that if you have two graphs and they look like this, they're both from my perspective, they're both positive slopes, right? But one's a little higher than the other. If they're like this, though, it's not that easy to tell. So you might, when asked to draw them for comparison, it might be good to exaggerate how steep one of them is and then exaggerate how gradual the other one is. So you can be assured that someone looking at your lab report knows, oh, this one was much steeper and that one's not much steeper. Okay. Or that one's very gradual or something like that. So that's something you want to keep in mind. And you want to know that no matter what the graph looks like, you are going to see, for instance, one graph that has a bunch of points and they look like they're random, but when you change the scale to where the distance is like 1 to 5 meters, then they all look pretty horizontal. That helps a lot. Uh, I have to run out and take something to my loving mother who just comes at the worst possible time. So let's take a 5 minute break, and I'm going to come back and finish this in a second. I'm going to go ahead and pause the video and take a break real quick. I just got to run this out to my mom, and I'll be right back. Y'all can ask questions when I come back, but I'm going to give you a full 5 minute break. So hold on for a second. I'll be right back. Sorry about that, everyone. I am back. We still got 3 more minutes, but you guys were welcome to ask me questions.
I'm looking at lab three,
Hmm.
and I see that you want us to draw graphs at some point. So you want us to just draw those out on our paper, then take a photo and upload it.
Yeah, you can even draw them electronically if you think you can make a neat enough job of it. That's fine. I've found the drawing electronically, even with the best of tools, is not very fun and not very effective. So, if you want to just draw them by hand and insert photos, that would be even better.
And in lecture, we're going to be finishing chapter two today, right?
Yeah, yeah, we should be finishing up chapter two. I might skip some of the derivation stuff to do it, but yeah, we'll finish up chapter two. Anyone else have any questions? All right, got 2 more minutes. Uh, I hit pause to record to pause the recording, but it says my screen sharing was paused. Are you guys not seeing the computer screen now?
No, sir.
Okay, that's weird. All right. So I think I just paused that rather than the recording. That's weird. Can y'all see the lab reports computer screen now?
Yes.
Thank you. I appreciate it. I'm glad Liam answered. Nobody else is evidently capable of talking. I'm just picking on you folks. I really don't. I understand. It's one of those things you just don't think about doing until somebody else already done it. All right, got 1 more minute. All right, it's time to go ahead and get started. So, as I was saying, this is the lab report that you normally do in class, but like I said, we have an addendum. I'm going to show you that in a second. Want to make some points about this. As I said, velocity versus time graphs, because we're only studying uniform acceleration or constant acceleration. That means our velocity versus time graphs will always, always, always be straight lines. You're starting to see that already because what we discovered was the position versus time would be like x versus t, and then the velocity versus time would actually be dx dt. And since it's dx dt, that means that it's the slope of the velocity versus time graph. And then the acceleration you're going to learn is the derivative of the velocity with respect to time. So if you make a velocity versus time graph, if the slope was actually changing, then that would mean the acceleration could not be a constant because the derivative of the velocity versus time graph is the acceleration, and therefore a changing slope would mean that that derivative is not a constant. And when that derivative is not a constant, that means obviously that it would be a curve that's not a straight line. Okay, so hopefully that helps. Later on, there will be, like I said, a lot of graphs here and stuff. There will be this quiz section at the very end, and this is where you get the chance to make sure you've figured out everything that you're supposed to figure out. And I told you there's some questions that I asked students in the motion detector lab, and I'm going to ask those same questions to you. I haven't given you that yet, but I will. So if you scroll down further and further, this is going to be, for instance, one of the labs that we do in classes with this air glider, and that's what we're seeing here. It's more or less like a triangular shaped, or actually it's more diamond shaped like this, aluminum object that's 2 meters long, and it's sort of like an air hockey table, and then it's got small holes drilled in the top surfaces so that it can give a little wafer of air that protects the glider that sits on it from touching the metal below, so it makes a very near frictionless surface. That air track, we're going to have a video of that, and you're going to measure the distance from the front edge of the glider to the front edge of the track and do a graph of position versus time and horizontal velocity versus time as well. But that's what that one's for. And I know that students sometimes don't understand what they're looking at in the video, so that's why I explained that. Now let's go to the quiz section. Here it is. So this is the section that says try to draw it first and then check back with the graphs you drew in the lab to double check. It also tells you you don't need numbers. I have found, for instance, in certain descriptions that it would be really helpful if you did write down numbers. So even though the lab says you don't have to, and you don't have to, I'm not going to take off for it. But if you're having a hard time explaining what parts of the graph are what, and it has something that has to do with time, like sometimes it'll say, describe a graph where you slowly walk away from, this is from last week, you slowly walk away from the detector and then you sit still for 5 seconds and then you rapidly walk back towards the detector. That kind of thing with that 5 second interval could be a wonderful place where you put the time as, some amount of seconds and then that same amount of seconds plus five or something like that. So by all means, feel free to use it, even though I'm not requiring it and they tell you don't have to. I'm just going to say that if it helps you, I would love you to put it on there, and I'm not going to take off for you putting the times on there. But these are the questions you're going to answer this week, and then what the lab that we had last week that you guys didn't take, they'll have questions that are actually quite a bit easier than this. But we have no problems with you doing this lab first instead of the second one. But that's part of the lab is you've got to turn this in, and I'm not necessarily going to grade it for correctness. I want it to be a learning experience for you, and then later I'm going to show you the right answers so that you can verify that you got the right ones, because the big thing that you're trying to learn here is how to understand position versus time graphs, velocity versus time graphs, and maybe even acceleration versus time graphs. So about those questions, okay? Uh, the questions that I try to tell you guys to focus on while you're doing the motion detector lab and the analyzing motion graphs lab is this. On a position or distance versus time graph, which is what this guy right here is, on such a graph, you might have a curve that does something like this. On that graph, what is the value of the distance from this horizontal axis up to a single point on the graph? So, what does this represent? What does that distance from the horizontal axis up to a point on the graph, what does that quantity mean physically in terms of motion? The second one is at any point on that graph, that particular graph has a slope. What is the importance and significance? What does that slope mean? For instance, if that slope is very steep, if it's a high slope and it's positive, what does that mean? What about if it's a high slope and it's negative? What does that mean? What about if it's a high slope versus a low slope? So a high positive slope versus a gradual or low positive slope. What about a low positive slope versus a high positive slope? That's what I want you to be able to answer on a distance versus time graph. Now, in addition to that, I want you to be able to answer the same thing on a velocity versus time graph. So both of those questions I just asked you about a distance versus time graph, what does the distance between the horizontal axis and a point on the graph, what does that vertical distance mean? What does it mean if it's above? What does it mean if it's below? But again, what does that vertical distance between the horizontal graph and a dot on the graph, or excuse me, between the horizontal axis and a dot on the graph, what does that vertical distance mean on a velocity versus time graph? And as all graphs have curves that have slopes at various points on the graph, what does that slope on a velocity versus time graph mean? What's the significance of it being a positive slope? What's the significance of it being a negative slope? What's the significance of it being a large positive slope? What's the significance of it being a low positive slope? What's the significance of it being a large negative slope? What's the significance of it being a small negative slope? All that stuff. Those are the big questions you're supposed to be learning from these two labs. Now I'm going to stop sharing this one and show you the addendum. Anybody have any questions before I stop sharing this? Okay, so I'm stop sharing that. Uh, what you'll notice on that module for week 3 lab module, you'll notice the other documents. So I've already shown you the three links within the page. I specifically showed you that we had analyzing motion.docx. That was what the document I was just looking at. Right below that was lab 3 analyzing motion graphs dash addendum docx. That's the document I'm getting ready to see you. And then the third thing was where you turn in your lab. So let me go ahead and share my screen with you guys. This time I'm going to share the addendum document with you. So this is the addendum, and it says, please download the Logger Pro app as instructed below. I would like at least one person from each lab group to make sure y'all download this. It says if you have Windows 10 or later, you're supposed to use this link. If you have Mac OS 10.15 or even 10.13 or later, you should use this link. And then for really old computers, you can do this stuff. I was able to download these two and didn't have any problems, but if you can't, you just got to let me know because we have a whole week to get this done. But the main thing is that's where these programs can be downloaded from. It has a password here when you do this. This is Climate, and I'm waiting for some time ago, may have been a whole year ago, may have been just a few months ago, I can't remember. The company that makes Logger Pro, Veneer, sent me or sent the physics department some documents. I'm waiting to find out if any of those documents are relevant to this. So if they are, I might find out during you doing this lab, and then I'll let you know, or I'll send it in an announcement/email. Okay. B, if for any reason you're not able to download Logger Pro, you can use the graphs that are provided. Remember to use straight lines and smooth curves in the graphs that you draw in the quiz at the end. Okay. So that's the actual addendum that makes this lab able to be done at home as opposed to just in class. So I'm going to stop sharing that. Anybody have any questions? All right, so it took me about an hour to do that discussion. I want to remind everybody again, chat me your first and last name if you haven't done so already. Also, text me and or email me if you have any problem with your name or your face or any other identifying thing to appear on my YouTube channel on my videos. If they are if you do have some objections to that, I need you to send me an email or text message immediately, and you need to tell me specifically what can't be on the internet, whether it's just you don't want your name up there, or you just don't want your face up there, or whatever. And in addition to that, for future reference, you might want to change your Zoom username to something like just your initials, or something. And then, always let me know who you are by doing the chat of the first and last name. Okay. All right. What I'm going to do now is I'm going to try to group you guys up in breakout rooms. So I'm going to create breakout rooms and I'm going to let you guys choose your lab partners that you normally work with. Let's see if I can find the breakout rooms. And I normally have, this is what, 20 some students. So in principle, we should have uh, eight students, or excuse me, eight breakout rooms. So I'm going to go ahead and make eight breakout rooms, and I'm going to let you choose your own breakout rooms. And the eighth one, we don't necessarily have to fill. Sometimes I have three or four students in a lab group instead of the normal just two or three. So if that happens to be the case, then we might have one breakout room not filled. I just want everybody to go to a breakout room. So I'm going to let the participants choose. I just created the breakout room and now I've opened them all. So, is everybody here from my class normally? Is there anybody here that's from my online class? I just want to make sure no one came in from my online class. Okay, it doesn't look like anybody is. So just feel free to communicate with each other. What I'll do is we've got Katie is moved to room one. So if you're normally a partner with Katie or Vincent, you might want to move to room one. Uh, if someone else is from another group, go ahead and move into room two, and I'll announce that person's name so everybody will know to go there. Zach is in room two. How about Cole? Will you grab a room, Cole? Because I know you. I think you normally work with Sarah and some other people. Might not be Sarah that you work with. I thought you did though. Uh, all right, so we got Zach and James are in room two. I've got Katie, Shane, and Vincent in room one. I got Cole in room three. Somebody that's not in one of those groups want to jump out. Liam's in room four. So I've got Liam in room four, Cole and Sarah in room three, James and Zach in room two, Katie, Shane, and Vincent in room one. And now I've got Monty's in room seven, and I've got Dylan in room five. And Mohammed Safdar, I'm probably horribly mispronouncing his name. I apologize, Mohammed. He's in room eight with Dominic. And Lewis and Gavin are in room six, and Monty's still in room seven. So everybody should be getting a room now. Get a room. Filthy animals. All right, Lily and Monty are in room seven now. I got Dominic and Mohammed in room eight. Gavin and Lois. and I think I said Lewis earlier. I think it's Lois in room six. Cameron and Dylan in room five. Chris and Liam in room four. Cole and Sarah in room three. James and Zach in room two. Katie, Shane, and Vincent in room one. At this point, if you don't know what lab group you're in, that's okay. Y'all only have one lab. It's not a big deal. Just jump into one. I would say jump into one that has only two students.
I have my lab partner here, but it's only we normally have three people and it's only me and Annalise in our lab group, so we might need another room.
Okay, that's no problem. Let's see if I can add a room. Yeah, I can add one. Okay, now I have room eight, so you can jump in that one. Now, you guys are not required to stay here the whole time, but what I'm planning on doing is I'm just going to be sitting here in case anybody needs anything, so y'all can come back and forth to me. I might send messages to everyone. They'll pop up on the screen by chatting when I send out a chat. But you can always come back out here and let me know. Or you could possibly text me because I'll be sitting here with my phone working on the computer. But come 12:30, I'm going to go ahead and convert it to class, and we'll actually be doing a lecture then. So I'm pretty much going to stop the recording portion right now or real soon, and you guys just work on your labs and get as much you can do as possible, and come ask me if you have any questions.
Hey, Prof, this is kind of embarrassing. I can't figure out how to get into a room.
Anybody help him on that? Because I'm not sure I know. Oh, it's gotcha. Let's see. From your standpoint, actually, let me just. I'm going to ask somebody.
I'm on the phone.
No problem. Uh, I'm asking a student right now.
I see it. I see it.
Okay, you did find it. Okay, cool. I should have known that off the top of my head. I apologize for not knowing ahead of time.
Hey, I was just looking at the quiz questions at the bottom, and I
Mhm.
don't know if it's just an error with how it got ported into Canvas, but the third question didn't have a graph on it for me.
Okay, make sure you download the document rather than just look on it on your computer screen. Sometimes that's the difference. If not, feel free to move it around and copy and paste another one because I give it to you in Word format. But yeah, that's fine.
Yeah, I've got it pulled up. I was gonna share my screen so you could see what I was seeing,
Gotcha.
see
Yeah,
how it ported it through when I downloaded it.
no problem. Is that what I just got a message saying you want to share your screen?
Yes. Um, yeah, so this is how it ported through for me.
There might not have been a graph for that part. Let me double check. I just want to look at it to make sure.
Well, looking here on the assign, like I can see it here.
Gotcha. I just flipped back to see that. And this is number three, you said?
Yeah.
Oh, yeah, yeah. There's a graph. Let me show you what it looks like on my screen just so you'll know. So I'm going to share screen real quick. I think that, yeah, that's the right one. So that's what that graph is supposed to look like down at the bottom. So you have a vertical velocity axis, a horizontal time axis, and then you have this is supposed to be line A up here, and this is supposed to be line B down here. It might even, no, I'm pretty sure the A is supposed to be up there with that line. I'm 100% sure of it now. And the B is supposed to be down here with this line. So that's what it's asking you on this.
Okay, I gotcha.
Does that make sense?
Yep, I was just
Thanks for
making
letting me
sure.
know. Yeah, it sometimes it garbles stuff. It's weird how Word can't keep its formatting right just from one version of Word in the Mac world versus one version of Word in the Windows world or something like that.
Yeah, it's wonderful.
Yeah,
Thank you.
no problem. Thanks for letting me know. Liam, did you have a question too, sir?
Just letting you know that I'm having difficulties downloading Logger Pro. When I click the link, a
Uh-huh.
window opens up for half a second, then closes itself.
Check your downloads folder. It when you click on it,
I
I think it
have.
just immediately
It's
downloads.
empty. It's
Okay.
empty. Yeah. So
Are you in a lab group with anybody else?
huh? I am. I am. I
Let's see if
left a
someone else
breakout
gets
room.
to do it. Hopefully, one of them will be able to get it.
Yeah, I believe Chris is doing that right now.
Okay.
And also, our room is the largest. Well, wait, no, I'm just not joined.
Oh, gotcha.
Still, you sent all the menials into my room. What's up with that, man?
I didn't want you to have any unfair advantages.
All right, cool. All right.
I think you meant millennials too, by the way. I'm sure that's what he meant. He didn't mean to call them those minions. There's me, menial people. That's funny.